Welcome everyone to this new video tutorial. We're going to see today two-dimensional histograms and back projection. So first, what is back projection? Let's take an example. We have, starting from this image, which is just the ground of a football pitch, we're going to calculate a histogram. Then, once we have the histogram, we take a second image, which is in this case this one, and we're going to find in this image all the parts that have the same histogram of this one. In this case, we're going to detect all the green background just starting from this image, and actually this one I cut it from the original image, which is this part, right? And why is it this important? This method is going to be useful later on, where we're going to see video analysis and cam shift algorithm to track object, because you can take, for example, an object, and then in real time we can track the histogram in the image and find where their object is, if it's moving, and so on. So keep in mind that this is really important thing to know of OpenCV. So let's start to do the work. We import CV2, we import numpy as np, and now we're also going to import from matplotlib import pyplot as plt. This is not really necessary. I'm going to import it just to show you the histogram. Let's first load the image. img, actually let's call it original image. Original image is equals to cv2.imRead go keeper.jpg, and you can download this image from the link in the description, or even better, you can use your own image. And then the ROI image, which is cv2.imRead pitch ground.jpg. I just call it ROI image from ROI region of interest, mostly because I took this from, so this part, this image is just I cut it from the original, that's why. So you can give the name you want actually. cv2 show original image, and let's call it, okay, original image cv2. Actually I don't like ROI image, let's say just ROI. cv2.im show ROI, and ROI key event cv2.wait key 0, and finally cv2.destroy all windows. Let's run the code and see if everything is correct, and it is. We have the original image and the ROI, which is exactly this part. I cut it from this, as you see. So what next? Now we need to convert the images to HSV format, color. So HSV original is equals to cv2.cvt color. So we're going to convert the original image and cv2 color underscore bgr to HSV. In some previous video I explained how HSV work. I don't remember honestly the video, it's some of the first at the beginning of the tutorial, so you can check that out. HSV ROI is equals to cv2.cvt color ROI and CV2.color BGR2HSV. Now, as I said before, we're going first to take the histogram of our ROI, so we need only this histogram. Histogram ROI, so it's going to be ROI hist is equals to CV2.calc hist of the HSV ROI channels, two channels. Okay, we've seen histogram in some previous video, but only single channel histogram, where basically we were saying how many pixels were like the concentrations of the pixel. You can check that video if you don't know what histogram is to understand what it is. Now we're going to see multidimensional histogram. So let's see what it is. So in this case, we know that HSV image is composed by three channels. First one is hue, second is saturation, and third is value. To create this histogram, we need to only get the first two channels, which are hue and saturation. So first channel 0 and second channel is 1, the index. And after this, sorry, I need to see what are the parameters. So first image channels, mask, histogram size and range. Okay, mask, we don't have any mask. Histogram size, so we know that HSV, so H goes from 0 to 179, so it has 180 values as even 0 is counted, and saturation goes from 0 to 255, so 256 values. And now we define this range from 0 to 180. In this case it goes from 0 to 179, but here 180, which is not included in the counting, and from 0 to 256. So we have the ROI histogram. Now first I'm going to show you the histogram, and then I'm going to explain what it is exactly. To show it, I'm going to command OpenCV and use matplotlib plt.imshow ROI hist and plt.show. Here is the histogram. You can see it's all violet color except this part here. So what is giving us this one? You can see that here from 0 to 180 we have the hue value. So hue, you can see it's around 40, this, and here from 0 to 255 we have the saturation value. So it's, you can see from 108 more exactly to around 130, around here. So this is giving us the concentration of two values, and we can see, so we can see more in details, for example, how it works. So we've seen in the histogram that hue was around 40 and saturation, the most concentration was around from 110 to 120, 25. So let's split the HSV ROI in 3 channels: hue, saturation, and value is equals to CV2 dot split HSV ROI. Now let's take a look at the hue channel. Let's print what's inside the array. For H in hue, print H. So you can see, as the histogram showed us, the concentration is from like 34, 40, and here is what we have. So 40, and you go here, and let's take a look at the saturation. For S in saturation, print S. And as we've seen in histogram, saturation from around 105, 10 to 120, 25, and a bit more. And here you can see that these numbers are similar to what we see in the graph. So that's why two-dimensional histogram is really useful in this case. But we are not interested to see it and to show it, so I can delete matplotlib and we can come back to OpenCV only. So now we can do the back projection. So back projection, again, from the histogram, we're going to look the same histogram but in the original image to see what matches and what not. And we can get a mask. So mask is equals to cv2.calc back project array. We're going to calc this in the original HSV image. Channels, we have 2 channels, so 0 and 1. The histogram is the histogram of our ROI. So it's ROI hist. The ranges from 0 to 180, from 0 to 256, and then we have also scale, and the scale is the original, so just let's put 1. Now we have the mask, so let's soon show the mask. cv2.im show mask. So this is our result. You can see that starting from this ROI, with the back projection we look the histogram of this ROI in this image, and we created a mask for everything similar to the histogram, in this case the green background. And you can see here the green background. What can we do now? Of course we can improve this. As you see, it's really noisy, so let's remove some noise, applying some filtering. In this case the best filter is the min filter. So filtering, remove noise, and you can check how filtering works. I've made a video about that in called smoothing images. So let's apply the min filter. The min filter is cv2.filter 2D, 2-dimensional, and we're going to apply it on the mask. The depth -1 and kernel. So we need to create a kernel. We can try to use, actually let's create a kernel that he is suggesting in the docs of OpenCV. So kernel is equals to cv2.get structuring element and cv2.morph ellipse and the size 5 and 5. So what is this kernel? I'm going to show you what is the kernel. For k in kernel, print k. So kernel in this case is just an ellipse and of size 5 by 5, so 25 pixel, and you can see 0 0 1 0 0, so this is going to create an ellipse. Kernel can be also different, can be for example a square, so it would be everything 1 or actually everything 0, it depends. Anyway, let's see the improvement of our mask after we apply the filter. And we see no improvement actually, so probably should say mask is equals to filter 2D. Okay, now we can see the improvements. It's really decent result. Can we improve this even more and remove some noise? Of course. What's the best solution? We can apply the threshold. As you can see, here everything is black and here there is some noise, so black it has the value of 0, white the value of 255, and here can be for example 30 and so on. So we can apply the threshold, and let's say everything more than 30 is going to be white and everything less is going to be black. So the mask will be is equals to cv2 dot threshold. So we're going to apply the threshold on the mask, and the thresh is going to be, let's put a threshold value of 30. The max value, the white will be 255, and the type will be cv2.thresh binary. And the threshold function returns us two values. So the first one, which we don't need, so we put just underscore, and we need only the mask, which is the second one. And let's see what we get with this threshold value. I think it's decent result. We can probably make it a little bit lower, maybe let's see 20. What do we get? I think it's okay. Now we can use bitwise operation to get only the green background. So as we've seen in the bitwise operators, if we have an image and we put a mask, so the white part is what we are allowing and the black part is what we are covering. And so in this case we are going to get only the green. To apply the bitwise operators here, we have to do something first, because we used to apply the bitwise operation on grayscale image, but here we have 3 channels, so the mask must be 3 channel as well. Mask is equals to cv2.merge, and we are going to put mask 3 times, mask and mask. Once we have 3 channels mask, we can get our final result. Result is going to be cv2.bitwise and our original image and our mask. At this point, let's show the original result. I mean, not original, let's show the result in show result, and result. Really good result. The problem is that this player has yellow color, which is pretty close to the green, so here we can have some faults. But anyway, we can maybe increase the threshold. Let's see, with 50. Okay, some improvement. Okay, maybe even more. Let's say 100. Okay, now I think it's a really good one. And this is all about back projection. Thanks for watching.